In Algebra 2, section 6.6, we're dealing with rational exponents. So, you remember that the root, sorry, this is supposed to be an n. So when I have something to the power of it, of a fraction, that denominator is the root of, right? So if this was b to the 1/2, 1 over 2, then that means I have to take it to the square root. So if I have 27 to the 1/3, this is the same thing as saying 27 to the cubed root, which you've dealt with these roots, and this is currency, so you know how to do it. This is just a way of writing it into a fraction. Okay? So if I factor this, the cubed root of 27 is 3. Right? Because 3 times 3 is 9 times 3 is 27. Now, this section then takes it one further, and if you have a denominator and a numerator, and if the numerator is something other than 1, then once you root it, you can square it, or you can not square it. You can you can power it. So the numerator is what you power it to, and the denominator is what you root it to. Okay, so this is, you could either first apply the power and then root, or you can apply the root then power. I like doing the root then power because I feel like the other way makes it complicated sometimes. But you'll need to use both methods when you're solving. And when you get stuck with one method, that's when you know to change the other. So if I do this, this means 27 to the 2/3 instead of the 1/3. There's a number on top. That means I'm going to do the same thing because this tells me that I got to cube root it. But then whatever answer I get, I have to then square it. So this becomes 3, so the cube root, right, of 27 is 3. But then I did to the power of 2, so my answer is then 9. Right? So let's try it. We have 49 to the 1/2, so this is the square root, and because it's square, I don't have to write the currency number because it's automatic. So this would be plus or minus 7. Right, because 7 times 7 is 49. Easy? Good. Now we're going to do it with 2/5, right? So this would be 32, and this is my root currency, so to 5th power, and then I'm going to, so I'm going to treat it like two different problems. First, I'm going to focus on this, right? If I look at all here, it might be overwhelming, but I'm going to treat it like two problems, okay? First, the inside. So just let's focus on just this right now. So I'm going to take 32 and I'm going to factor it. 8 times 4, 4 times 2, 2 times 2, 2 times 2. So there's 5 2s. So this is root 5 times 5 times 5 times 5 times 5. Okay, and my currency is 5. So I have a whole set of 5s. My currency is 5. Right, so I have a whole set of 5, so this would be just 5. Right? So once I do that, then I just apply the square, which is 25. If I did it the other way, it could be the same thing. I could square 32 and then find the 5th root of it, but to me that's more work because that's more that I have to do this, so I'd like to square at the end. But it's ultimately both ways works, so it's up to you. So if that makes sense, go ahead and pause it, write it down. I have one more board. Alright, so on this one, if this is the same base, then I can do the same thing that I'm doing with if the base is the same and I'm multiplying these out, then I just add it. So this becomes y to the 1/7 plus the 4/7. Now, if of course it's not the same denominator, I have to change that denominator. But because we're lucky enough that it is, it's y to the 5/7. And because I can't do anything with the y, I'm just going to leave it in that answer. The next one is a little bit more complicated because it has that negative on there. And so that negative basically means this is on the wrong side. It doesn't mean I apply the negative to the x, if you remember. It just means that I have to then go 1 over x to the 2/3. And once I move it down, the 2/3 becomes positive. So I'll do the same thing, except it's going to be on the bottom. So 1 over x to the cube root squared. But I think if you just leave it like that, it would be the same also. Yes. Or you can change this into the fifth root to the seventh root. To the seventh root. Okay, the next one, this one, I can't really do much of anything on it, but I do need to do, if I put it in fraction, it might be helpful, right, to use the rule. So this is 16 to the 1/6 divided by 2 to the 1/3, right? Now division, multiplication, when I multiply them, I have to add the exponents. But this one, I subtract it. But I have to have the same base. Now this doesn't have the same base, right? So let's see if I can turn 16 into the same base. So we have 16 is 8 times 2, 4 times 2, 2 times 2. So this base is 2. And I can rewrite 16 to be 1, 2, 3, 4. So this would be this would be 2 to the 4th. I haven't changed anything because 2 to the 4th is still 16 to the 1/6 over 2 to the 1/3. Right? And now what I can do is when I have a power to power, the rule, if you remember the rules of exponents, if I do a power to power, I just multiply them. So 4 times 1/6 gives me 2 to the 4/6 over 2 to the 1/3. Right? And now, because they're the same base, I can do 2 to the 4/6 minus 1/3. The problem is, unlike this one, I don't have the same denominator, okay? But because I can either reduce this to base a denominator 3, or I can multiply this by top and bottom, which I'm going to do. Multiply it by 2, I end up with 2 to the 4/6 minus 2/6. So this gives me 2 to the 4 minus 2, 2/6, which is the same thing as 2 to the 1/3, which is the cube root of 2. So if you can leave it in that answer, you can do the cube root of 2. For number 6, now I can't take anything out because it's 4x to the 4th. And the currency is 6, but I might be able to reduce it, and I can figure that out by putting it into a fraction. So a fraction for exponents. So this would be 4 to the 1/6, right? And this would be x to the 4/6, right? And I can reduce this to 2 squared to the 1/6, and then x to the 4/6. And 2, remember the exponents like this one, when they have it, I multiply it. So this would be 2 to the 2/6, x to the 4/6. And if I reduce, these are being multiplied. If I reduce this, this would be 2 to the 1/3 times x to the 2/3. So then I can reduce this. This would be, they're both cubed. See that? Cube root. This is 2 to the power of 1 because the numerator is 1. And then x, the numerator is 2 squared. So I just reduce it. So go ahead and try page 425, number 7 and 8, 425, number 7 and 8. I will see you in class.